Rational equations. Rational equations. For problem A, we have x plus 2 all over 3 minus the fraction x minus 1 all over 5 equals the fraction 1 over 15. Now notice this is an equation, so I suggest you draw a line at the equal sign to indicate the left side and the right side. First thing you probably noticed is we have fractions. Well, look back and see. Are they speaking the same language? Meaning, do they have an LCD or a common denominator? Since they currently do not, take a moment now to identify the LCD. Hopefully you identified the LCD to be 15. Now let's go back and rewrite each fraction with this LCD. The first fraction, notice, has a denominator of 3, but I need it to be a 15. So what must we multiply by? We must multiply by 5 over 5. Now that means you are multiplying the numerator x plus 2 by the value of 5, which means you will need to distribute, which gives you 5x plus 10. The second fraction currently has a denominator of 5, but we need it to be a 15. So what must we multiply by? 3 over 3. And again, we are multiplying, so you will need to distribute in the numerator, which gives you 3x minus 3. And on the right side of the equation, notice we already have the common denominator of 15, so there's no changes, so that will remain a 1. Now that all the fractions are speaking the same language, we're now ready to simplify each side of the equation. Notice the left side of the equation, we are being asked to subtract two fractions. And so since we have a common denominator, we can now write it as a single fraction, but keep the common denominator. When you merge these two fractions into one, you must use parentheses. Now we want to simplify the numerator. So check in front of the parentheses and see if anything needs to be distributed. Notice we did need to distribute the negative, so there are a few sign changes. From here, go ahead and combine your like terms. And at this moment, you should have 2x plus 13 all over 15 equals the fraction 1 over 15. So since we have simplified the left side and the right side, we look at the equation as a whole. And we notice we have fractions. And now we are going to wipe out the fractions by multiplying each side of the equation by the LCD using the multiplication property of equality. In this case, our LCD, or common denominator, is 15. So we are going to multiply the left side and the right side by 15, or 15 over 1. Why do we do that? Well, remember, if you're multiplying values and you have a common factor in the numerator and in the denominator, they can reduce to a value of 1. Well, that happens on the left side of the equation and the right side of the equation, which reduces to a much simpler equation of 2x plus 13 equals 1. Now that we've gotten rid of the fractions, this equation looks a little easier on the eyes. Let's solve. First step should be to subtract 13 on both sides. Divide both sides by 2, and you should have found x equals negative 6. But wait, that's not your final answer necessarily. You have to check your solution and the domain. That means you have to make sure your original problem, the denominator, would never equal 0. So go back to the very beginning, to the top. If you were to plug in the value of negative 6 into the original problem, would any of your denominators equal 0? And it turns out it would not affect your denominator, so you can keep the value of x equals negative 6. Problem B, we have 5x over x minus 1 equals 5 over x minus 1 plus 3. Again, I suggest you draw a line at the equal sign so you see your two sides to the problem. Notice we have fractions. Is everything speaking the same language? Well, it appears so, except for 3 is not written as a fraction. How do we make 3 into a fraction? You simply place it over 1. Now, are all 3 terms written with a common denominator? No, they aren't. So we need to force all of them to have a common denominator, and in this case our common denominator is x minus 1. Looking at the first fraction on the left side, 5x over x minus 1 already has the common denominator, so the numerator will remain. The next fraction also already has the common denominator, so the numerator will stay. But the 3 over 1 does not have the common denominator. So we will need to multiply the top and the bottom by x minus 1. And when we do that, we must distribute the 3 in the numerator. 3 times x and 3 times negative 1. From here, we are now going to simplify each side of the equation. On the left side, there's nothing to simplify. On the right side, you have two fractions and you're being asked to add the 2. So now that you have a common denominator, keep your common denominator, but when you merge the two fractions, make sure you use parentheses. From here, simplify the numerator on the right-hand side of the equation. Once you've simplified each side, you will see you have 5x over x minus 1 equals 3x plus 2 all over x minus 1. Now we want to clear out the fractions by multiplying each side by the LCD. In this case, your LCD is x minus 1 or x minus 1 over 1. Remember, what you do to one side, you must do to the other side. Notice you have common factors in the numerator and denominator, so they reduce to a value of 1, which leaves you with the equation 5x equals 3x plus 2. Now that you have a regular or more comfortable looking equation, go ahead and take the time to solve. You should have subtracted 3x on both sides, then divided both sides by 2, and found that x equals 1. But before you say that's your final answer, you will need to check your solution and the domain. Recall, the denominator cannot equal 0. If you plug in your solution back into the original problem, will it cause the denominator to equal 0? Well, 1 minus 1 does equal 0, which means we cannot keep that solution. And if we don't have an answer, what do we say the final answer is? We say it has no solution. Problem C, a minus 2 all over a plus 3 minus 1 equals the fraction 3 all over a plus 2. Again, I suggest you draw the line at the equal sign. Again, notice we have fractions. Are they speaking the same language? Meaning, do they have the same common denominator? And they do not. So take a moment now to find the LCD. Hopefully you found the LCD for all three fractions to be made up of a plus 3 and a plus 2. We now need to multiply each fraction so that it can be written in the equivalent form. The first fraction currently has a denominator of a plus 3, so we must multiply it by a plus 2. That means in the top you have the binomial a plus 2 times a minus 2. You will need to multiply those, and you will get a squared minus 2a plus 2a minus 4. Now the fraction in the middle, 1 or 1 over 1, will need to be multiplied by both pieces, meaning we need a plus 2 over a plus 2, and we need a plus 3 over a plus 3. Well, lucky for us, we have a 1 multiplying these two values, so we're mainly concerned with a plus 2 times a plus 3 for the numerator. When you distribute, you will get a squared plus 3a plus 2a plus 6. On the right side of the equation, notice we already have a plus 2, but we are missing what piece? We're missing a plus 3. So now you would need to multiply the numerator, 3, and distribute it to a plus 3, which gives you 3a plus 9. Now let's take a moment to simplify the numerators individually. And now we want to simplify the problem. On the left side, you're being asked to subtract two fractions, so you can now write them as a single fraction since they have a common denominator, but make sure you use parentheses. Once you combine them into a single fraction, see if there's any sign changes, and continue simplifying the numerator. Now that we have negative 5a over 10, negative 5a minus 10 all over a plus 3 times a plus 2 equal to the other fraction of 3a plus 9 all over a plus 3 times a plus 2, we are now ready to wipe out the fractions by multiplying each side by the LCD. In this case, our LCD is made up of a plus 3 and a plus 2. Remember, what you do to one side, you must do to the other. And now that we have common factors in the numerator and denominator, you can reduce each side of the equation, leaving you with negative 5a minus 10 equals 3a plus 9. From here, solve the equation. Hopefully, you found a to equal negative 19 over 8. Now remember, once you have your solution, take a moment to check and make sure it will not make the denominator equal 0. It doesn't, so that is your final answer. Here's your try it. Let's see how you did. Okay, notice they were fractions. Hopefully you found the common denominator to be n minus 8. The first fraction already had the common denominator, so the numerator remained a 1. 1 can be written as 1 over 1, but it needs a common denominator of n minus 8. So that is what you multiply by in the numerator and denominator. And then the other fraction, 7 over n minus 8, also already had the denominator, so it will remain the same. Now you want to simplify each side of the equation. On the left side, you have two fractions that are being asked to subtract, so you combine them by keeping the common denominator. But when you merge, make sure you use parentheses. Simplify the numerators. From here, multiply each side by the LCD, which reduces and leaves you with negative n plus 9 equals 7. From here, you will solve for n like you would normally by subtracting 9 on both sides. Divide both sides by negative 1, and you should find n equals 2. Make sure you check the solution and the domain. This will be your final answer. Problem D. P plus 5 all over p squared plus p equals the fraction 1 over p squared plus p minus the fraction p minus 6 all over p plus 1. Again, I suggest you draw the line at the equal sign. Notice we are dealing with fractions. Are they speaking the same language, meaning do they have an LCD? By looking at the fractions, notice the denominators are not in factored form, so take a moment to factor them, please. Your first fraction should factor into a denominator of p times p plus 1. On the right side of the equation, you also have a denominator of p plus 1, and then you already had p plus 1. Take a moment now to identify the LCD. Hopefully you identified the LCD to be made up of p and p plus 1. Let's look at our first fraction on the left. Notice it already consists of the common denominator, so the numerator will remain a p plus 5. On the right side of the equation, the first fraction again already has the common denominator, so that too will remain the same numerator. But the third fraction is only made up of p plus 1. What piece is missing? If you notice, it is missing the factor of p, so we need to multiply the numerator and the denominator both by p. In the numerator, you have p times the binomial p minus 6, so you will need to distribute, which gives you p squared minus 6p. Now we want to simplify each side of the equation. On the right side, you are being asked to subtract two fractions, so write it as a single fraction, but when you merge, make sure you use parentheses. Now go ahead and simplify the numerators. And now notice, we want to wipe out the fractions by multiplying both the left and the right side of the equation by the LCD. In this case, the LCD is made up of p and p plus 1. Again, what you do to one side, you must do to the other side. Now that we have common factors in both the numerator and the denominator, they reduce to a value of 1. And we are left with the equation p plus 5 equals 1 minus p squared plus 6p. Now we're going to solve the equation. Notice this one's different. We have a p squared, which means we are dealing with a quadratic. If you notice, p squared is not positive, it's currently negative, which means we need to move everything to the left side of the equation. When you move everything to the left side, you are left with p squared minus 5p plus 4 equals 0. Since we have a quadratic, we have to remember the rules. A quadratic must equal 0. Once it equals 0, then we use factoring as our tool, meaning check first, do they have anything in common? Notice they don't. So our next step is to do the AC method. So take a moment to go ahead and factor this into its two binomials. Hopefully you found your factors to be a p minus 4 and p minus 1. Since we have two binomials, that means we have two factors. Let's look at the first one. P minus 4, we take that piece and set it equal to 0, and we solve for p, and we find p equals 4. But remember, you must check your solution and the domain. So take your p equals 4 back to the very beginning and plug it into the denominator. Will it cause any of the denominators to equal 0? And it turns out it will not. So we will keep the answer p equals 4. Now look at your other factor, p minus 1. We have to investigate that. So take p minus 1 equals 0 and solve for p, and you should find p equals 1. But again, we're not done. You have to take that back to the original problem and check each and every denominator. Will any denominator equal 0? It turns out it doesn't, so we will keep the answer p equals 1.